So here's the setup for the simple harmonic motion. So you're going to have a force sensor up here. You're going to have a motion detector down here. The force sensor is going to be plugged into the first Pasco port down there on the bottom, and the motion detector is going to be plugged into the channel 1 and 2 there, and the yellow one needs to be in channel 1. Okay, once you have this whole thing set up, you can press the power button there and it should light up blue when it's on, and then we can start getting everything together. So in this case we're going to need a mass hanger, and so we're going to put the mass hanger on the spring, and we're going to leave everything as it is for a moment. So let's go ahead and start the capstone program. All right, so now we've started the capstone program. We have these different pieces on here. I'm going to go ahead and tear this. You see this 0 button right here? I'm going to tear this. And what that's doing is it's basically just saying, hey, this thing on here, we want to neglect that. We don't want to measure that. So we're going to set this as our 0. The other thing we're going to do is we're also going to set our 0 for this. And we're going to have to come here first and foremost, though, we've got to come over here to the hardware setup and set everything up. So, remind me later. So, hardware setup, so we're going to open that up, and you're going to see the Pasco interface of the box, and it already has the force sensor is already set up here. We need to actually put the motion detector on there, so let's click on that port number 1 and scroll down. All right, scroll down, and we'll go down to motion sensor, and then we'll click motion sensor. So now we have the motion sensor and the force sensor are both hooked up, and let's go make sure of that. And we can see it there. So high resolution force sensor, and it measures force, and we have the motion sensor, and it can measure position, velocity, and acceleration. Perfect. All right. So in this, I'm going to go ahead and click that off so we can see the screen. And so what we're going to do here is we're going to actually measure this spring constant by adding a bunch of weight to it, and then seeing the displacement. And then we're also going to add some weight to the spring, and we're going to displace it and let it go and watch it spring do this, and it'll have some periodic structure to the graph, and we can do our calculations with that. So first things first, we're going to do the spring constant. So let's go ahead and go over here to table, and I'm going to just double click table, and it's going to bring up a table. Now I want to add a third column to this, and so what I'm going to do is come up here to this top left hand corner, and you can see insert empty column. So I'm going to do that, and now we have 3 columns. So what do I want to do? I want to set this, this has already been set to 0, and I want to set this to 0 now. And so I'm going to click that, and you'll hear some clicking, and it's basically setting that distance to 0. What I want to do now is I want to come up to this table, and I want to select on this one I want to have force. On this one I want to have my position where it is. But this one over here I want to do some not user entered data. I want to do some calculated data. And so I'm going to come over here to the calculator, and what I'm going to do here, and I'm going to show you this time because I want you to see that it's kind of precise in what you need to do. But I'm going to type in here displacement because I want to know the displacement. So displacement equals. And what I want it to equal is this initial position, which I've already set as 0. So I'm going to say 0 minus the position. In other words, the new position, if I put some weight on there, it's going to go down. And so I want to know what that distance that it went down is, not the distance it is from this. And so I'm going to say minus, and I'm going to say position, because we want to see the difference in the position. So the key here is you have to capitalize the P, because you see here it's capitalized. It has to look identical. And so I'm going to type in position, and then I'm going to come to the next block, and I'm going to select the units. Units is meters. And we'll just type M, and that'll bring up the meters. And there you go. So displacement equals 0, or the 0 setting, minus this position, right? And so that should be good. We're going to just come down here to the properties. You'll see that there. All this is laid out in your what's going on with my properties. There it is. I'm going to come to numerical format. I'm going to make this 3 decimal places, and everything else looks good. So I'm going to say OK. And now I'm going to come over here to my third column. Well, I'll put that away. I'll click on the calculator. I'm going to come over to my third column, and I'm going to say OK. Now this one, I want displacement. And so now I have my 3 columns. I have force, I have position, and I have displacement, which is a calculation of this minus this initial position that it's in. Okay, so to do this though, we're going to have to change this recording type from this constant recording to what we call keep mode. And so keep mode will allow us to select different moments when we're doing the measurement at which we want to keep that specific data. Okay, so now everything is set up. We're pretty good. We can go ahead and get ready to start. So let's go ahead, and I'm going to press preview. And so at the preview, this should be very close to 0, this should be very close to 0, and this should be very close to 0. And so I'm going to, down here at the bottom, you'll see the check mark, and I'm going to say keep sample. And so now we have the first initial set of data that we want. So in the lab, it tells you to do a couple extra, but I'm going to skip through and just do a few of the bigger ones. So I'm going to add 20 grams to here, and then try and get it so that it stops moving, more or less. And I'm going to say keep, and I'm going to add 20 more grams. And I'm going to say keep. I'm going to add 20 more grams. And I'm going to say keep. And I'm going to add 20 more grams. And I'm going to say keep. All right, so you'll have a few more data points than that. But now I can stop the recording. And we have the data. So what did it do? It's measuring the force that it feels from this mass hanging on there. Then it's measuring what that position is relative to this thing. And then we've done the calculation, well, how far is it from where it started? In other words, how far did it go down each time that I added from that initial position? All right, so now we have our three pieces. We need to go ahead and we've got to go ahead and do our graph for this to figure out what our spring constant is. And so what we're going to do is we're going to come over here to graph. I'm going to double click graph, and it'll bring up a graph here. And I'm going to click here, and I'm going to click on this one. I'm going to click force. So on that one, I want force. On this, I don't want index. I want this to be displacement. And so now I have displacement. So now we have force versus displacement. And the slope of that should equal something very, very valuable, something that we want to know. I won't let the cat out of the bag just yet. Okay, and so what we can do here is we can come up here to the highlight. We can highlight the box and, oops, move that box so that it has the data points that we want to look at. And we can come here up to the top. You'll see this line here. And we can click linear because that's what we want. This is for trend lines. And so now we have the linear trend line. And so these points have this linear trend line, and there's the slope, the the y-intercept, and so on and so forth. All right, so now we've got the first one. We can figure out what the spring constant was. And right now I have basically 80. And so I'm going to add 2 more. And now I've added 100. It's actually 105 because of the mass hanger, but in this case, I'm not real worried for this setup, right? So in this case now, I want to go over here and I want to do a whole new set of measurements. I'm not really worried about what's going on. I want to do this. So I want to come back over here, and at the top corner here, I want to add a page. Now I've added page. What do I want to do here? Here I want to have 3 graphs. So I'm going to double click, double click, double click. Now I have 3 graphs. Here, first one, I want to have a position graph. And I want this to be versus time. And here I want to have a velocity graph. And I want this to be versus time. And here I want to have an acceleration graph. And I want this to be versus time. And so now, this is just run 1 that you're seeing here. When we start the next run, this will all go away. It'll keep the other runs, but it'll record new data while saving the old data, and you can kind of go back and forth between it. All right. So now what do we want to do? So I want to set this height now as my 0. Try and get it to stop moving just a little bit. So I'm going to set this at 0. So I'm going to come down here to the bottom, set that at 0. I'm also going to increase the rate of measurement. In other words, right now we're at 20 hertz, so it makes 20 measurements per second. But I want to make this 50 for this one. I want to have more measurements per second. So we're going to do 50 hertz. And it's already set up for motion sensor, and we're going to have to change this from this keep mode, and we're going to have to go back to continuous mode. Okay, and so now we have everything set up. We have our 3 graphs set up. We have our weight is hanging on the force sensor. That's set up. We've got that zeroed. Let's just make sure that's zeroed. So now you hear the little clicks every time you click 0. And so now we should be good to go. And so what I'm going to do now is I'm going to go ahead and I'm going to press record. And now I'm going to pull this down about, 10-ish, 5 centimeters, 10 centimeters, something like that. So that it starts going up and down. And we just start recording that data. You can see it's recording nicely. We'll let it go until we at least have like 10-ish runs or something like that. And I'm going to go ahead and press stop. Kind of cool actually, because you can see the dampening of the wave. It's really kind of neat. There's a lot of stuff going on in here that we could talk about. But for the purposes of this, we don't need all that. What we do need here is we need to go ahead and elongate that out a little bit. This was our first wave. And so if you just grab and click and hold on the axis values, you can actually drag that out, and you can actually click and hold in the center of the graph somewhere, and you can move that whole thing around. So if you need to, put it where you want it, so to speak. So on this one, I'm going to go ahead, I'm going to just bring that down just a little bit, and I'm going to stretch that out a bit. All right, and same with this one. I'll bring this down just a little bit and over and stretch it out a little bit. Okay, so now we have our 3 graphs, and they all look very nice actually. And so what we need to do is, with these graphs, we can fill out the rest of the information for the lab. And really what you're going to be considering is you need to consider you're going to determine the period. So in other words, we need to take one of these coordinate tools up here, right? And we're going to add a coordinate, and you'll see it show up there. And so what you're going to do for the first bit is you're going to figure out how long did it take to go between these crests. In other words, to make one full wavelength, because a period, as we discussed, is one full wavelength. And so we have the first time, you can see, is 11:26. The second time, 12:1. The third time, 13, right? And the next time is 13:9, and the next time is 14:7, so on and so forth. So you'll record those times as they go by, and you'll record those on your chart in the lab report, and you can figure out your period, right? How long did it take? So final minus initial, so on and so forth. Then you're going to use the coordinate tools over here as well. And for the second part of the second table, you're going to just need to fill out the one crest and the one trough for each of this lab and for this measurement and the acceleration measurement. And so now we're up here at the top, and so the first one, the velocity is 0.78, and then we go down to the bottom, and the velocity is minus 0.77, right? Because we're at the bottom, we're going the other way. And so now we have the top and the bottom, and we can figure out the amplitude of the velocity that way. Then we can come over here, and we can do the same thing again with this one. And you want to use that first wave, that first nice wave, if you can. And so here we have the acceleration is 5.4, and at the bottom we have negative 5.4, which means it stops and accelerates up, and it goes up and it accelerates back down, and so on and so forth and so on and so forth, right? Okay, so that is the nuts and bolts of this lab. This has all the pieces that you need. You can fill out everything else from there. You don't need anything else. And so with that being said, I will see you in class.